Good morning, my dear students. Today I'm going to explain the heat exchanger device. Where our agenda today is explain the main concept of the heat exchanger, NTU method, different types of the heat exchanger, and solve one example. In the previous class, we have explained the both types of the flow in the heat exchanger, which is the parallel and counter flow, which is the basic concept of the heat exchanger. These two types of the heat exchanger, it could depending on different parameters. The most important parameters are hot temperature in, hot temperature out, cold temperature in, cold temperature out, and mass flow rate of the each pipe. This could help to calculate the number of transfer units. NTU method, depending on the capacity, which we have cold and hot capacity, depending on the pipe. So the capacity we have explained in the previous class is equals m dot multiplied by Cp. So based on this, we have to find the C minimum based on the numbers of the mass flow rate and the Cp that we will be able to find it from the table. This also could help to calculate the ratio or the capacity ratio by finding the C minimum and C maximum. The C minimum could help us to calculate the Q maximum, where the heat maximum is depending on the temperature of hot end and temperature of cold end. Also, the most important of this kind of the heat exchanger method that is to identify which one is the working fluid. Is it the cold pipe or the hot pipe? While by identifying the working fluid and calculating the Q maximum, we will be able to calculate the effectiveness. This effectiveness, it will help us to calculate the NTU method by using these types of the tables. So, by finding the NTU, we'll be able to use the effectiveness by using the table of the heat exchanger effectiveness relation. So, we have effectiveness, NTU, and capacity ratio, where all these types of the arrangement depending on these three parameters from the effectiveness, NTU, and the capacity ratio. So the flow arrangement, we have multi or different types. We have parallel flow, counter flow, shell and tube, where we have one shell and multi-tubes, or multi-shells with multi-tubes. Also, we have cross flow in single pass, where the both fluids are unmixed, or when the C maximum mixed, C minimum unmixed, or C minimum mixed and C maximum is unmixed. Also, we have all heat exchangers where the capacity ratio is equal 0. So we have two tables of the calculation of the formulas to calculate the NTU or the effectiveness. It's depending which one is provided in the question, which one is missing from the question. Also, we have charts that could help us to replace the formulas from the two tables that we have explained just now. So, the charts that related to effectiveness, NTU, and the capacity ratio. So, each one of them has different arrangement of the capacity ratio that could help to change the numbers for the NTU and the effectiveness. So, we have 6 charts: parallel flow, counter flow, we have shell and tube for single pass or single shell and multi-shells. Also, we have for the mixed and unmixed. So this kind of the information that will help us to solve this example and all the questions of the heat exchanger. So this example mentioned that hot exhaust gas. So from the beginning of the question, we have to identify and analyze the question. In the hot exhaust gas, which are entered finite tubes, cross flow, so we have cross flow, heat exchanger at 300 Celsius and leave at 100 Celsius. So based on this, we have note that it is hot, mean this is a hot pipe. So we have to know, is it this one is a working fluid or the assistant fluid for the working fluid pipe? So he mentioned also are used to heat pressurized water. So from this sentence, we have noticed that the water is the working fluid and the hot gases is the assistant fluid to heat up the whole water or pressure the water inside the pipe. So the water is at flow of 1 kilogram per second from 35 to 125. So we can notice here that the water have entered at very low temperature comparing with the inlet of the hot pipe. But at the exit pipe, the cold water have been raised more than the exit of the hot pipe. So in the counterflow, it may reach higher than the hot pipe. So the overall heat transfer coefficient based on the gas side surface area is equals 100. So this one, it will help us to calculate the NTU or the information or the relationship inside the NTU formula. So now the question mentioned, determine the required gas side surface area using NTU method. So when the question mentioned in the question that you have to use the NTU method, so you have no other choice to use another formulas. So based on this, we may able to calculate or to find the CP from the table. So after this, we may able to calculate the capacity in the cold part because the both temperatures are provided in the question. After this, we may able to calculate the capacity hot by using the energy balance for the hot and the cold. So based on this equation, we will be able to calculate the C hot. Then we will identify which one is the minimum based on the numbers based on the result of the question. After this, we will be able to calculate the heat maximum by finding the C minimum from both parts with the differential of temperature of the inlet for the hot and the cold. After this, we will be able to calculate the working fluid of the cold because based on the question, the water is the working fluid. By finding the working fluid, we can use the effectiveness formula by finding working fluid over the heat maximum, also to calculate the capacity ratio. From the capacity ratio, we will be able to go through the chart, unmixed chart, so to calculate the NTU. From the NTU, we'll be able to calculate the area of the hot pipe because the question is looking for where the overall heat transfer coefficient is provided as equals 100 and the C minimum we have identified by using the energy balance formula and the capacity formula. Thank you.